Today, we're going to learn how to use the stack data structure, more specifically, how to convert a postfix expression into assembly. Hello, I'm James Helfrich. The stack can be used in a wide variety of different applications, some of which are kind of unexpected. Today, we're going to learn how to turn a postfix expression into a prefix expression, and this prefix will be in an assembly language. As a review, infix notation occurs when the operator is between the operands, 1 plus 2, where plus is the operator, or 1 and then a plus sign and then 2, where plus once again is the operator. Postfix notation occurs when the operator is after the operands, like they take 1 and 2 and add them, where add happens after the 1 and 2 operand, or 1, 2, plus. Now, assembly language is similar to machine language, the programming language of a CPU. This is a form of prefix notation where the operator is before the operand. So add 1, 2, where add is the operand, or add 1, 2. Okay, so we are going to use an abbreviated form of assembly language. And here are the assembly language commands: load, set, save, add, subtract, multiply, divide, modulus, and exponent. So if, for an example, I want to add b plus 12, I would say load b, and b goes into the register, add 12, and take the result, which is in the register, and save it to A. Okay, so here's my input, which is in postfix notation, 4, 5 plus 6 times. Now what I'm going to do is I'm going to push the operands onto the stack, and the operators will get converted to output. So first of all, I'll say 4. Now 4 is an operand, so I push it directly onto the stack, and there'll be no output. And then I'll say 5 is an operand, so I'll push it onto the stack, and once again, there's no output. And then I say 6 is a plus. Now plus takes 2 operands, so I'm going to pop the 4 and the 5 off the stack, and I say 4, set, add 5, and those are the 2 I popped off the stack, and I'm going to save it to A. And A, I'm going to push back onto the stack. Now I'll say 6, which is an operand, and I'll push it onto the stack. And that did change the output, not at all. And then I'll say multiply. Multiply is an operator. So I'll take the 2 items on the stack, A and 6. So I will load A, add or multiply 6, and then save it to B. Load A, multiply 6, and save it to B. Now B is on the stack, and B is the result of the expression. This is example 11.5 from the C++ data structures textbook.